What is the speed of a particle of mass 10 raised to the power of minus 27 kilogram whose wavelength is 10 raised to the power of minus 8 meters? H, which is our Planck constant, is given as this, right? They ask us what is the speed, which is c. This is what they ask us, c, right? And what is given, mass is given, our m is given as 10 raised to the power minus 27 kg. What again is given, wavelength, which is lambda, is given as 10 raised to the power minus 8 meters, right? Then my Planck constant H is given as 6.63 times 10 raised to the power minus 34 joules second, right? Good. Now, please can you stay with me for some background explanation to some formulas before we can able to answer this question, right? So let's go there. Before we can find our speed, we should recall that energy of a photon, right, is equal to change in mass, or mass times c square, right? Why? Because it has been considered that the photon has two nature, right? The particle nature and the wave nature, right? Good. So we should know this famous equation. Let's call it equation 1. Good. Now also, the energy of that photon is the same thing as what? Hf. Planck constant times the frequency, right? And we should recall that my speed of light is equal to wave frequency times my wavelength, which is my lambda, right? Now if I make f the subject formula by dividing both sides with lambda, this will cancel this, so my f is equal to what? C over lambda, right? The next thing is, from this, let me say equation 2, I'm going to replace where f, I'll replace it with this. Good. So what am I going to have? I'm going to have E is equal to C, Planck constant times C over lambda, right? This is equation 3. Good. The next thing is, let me equate the equation 1 and equation 3. All are energy, right? So what I'm going to have is mc squared equal to hc over lambda. Good. Now the next thing is, I'm going to cancel out what is common. C here will go, 1c here will go, 1c will remain. So what I have is mc equal to h over lambda, right? What I'm asked to calculate is my c. So I need to make c the subject formula by dividing both sides with m. Good. So here I'm going to divide by m. Dividing here simply means times 1 over m, right? M will cancel m, so my c is equal to Planck constant, this lambda m. Good. Alright, before we proceed to the final answer, thank you for how far you've been with me. If you have not subscribed to the YouTube channel, please kindly subscribe to the channel. If you are not following the Facebook page, kindly follow the Facebook page. Share the video with your family and friends, right? Thank you. Let's proceed to our final answer. Okay, so what I'm going to have is, my Planck constant is given as 6.63 times 10 raised to the power of minus 34 divided by my wavelength, right? My wavelength is given as 10 raised to the power minus 8 times my mass is given as 10 raised to the power minus 27, right? Good. So let's perform simple mathematics, applying law of indices here. You don't need a calculator here. So what I'm going to have equal to, bring my numerator to up at 6.63 times 10 raised to the power minus 34, right? Divide by, this is simple indices application. I have 10 times 10, that is, if I multiply what have If I multiply that which have the common base, that is 10 and 10, I'm going to add their power, right? So that simply means I have 10 raised to power minus 8 plus open bracket minus 27. This is simple indices application. So let's proceed. What I'm going to have here is 6.63 times 10 raised to power minus 34 divide by, I'll open my bracket, this times this will give me minus. So what I have is 10 raised to the power of minus 8 minus 27, right? Good. So next thing I'm going to have is 6.63 times 10 raised to the power minus 34 divide by minus 8 minus 27. What am I going to have? I'm going to have, this should give me minus 35. So what I have here is 10 raised to the power minus 35, right? Good. I'm going to apply another law of indices, all right? So what I'm going to have is, if I'm dividing that which have the same base, I'm going to do what? Subtract their index. So what I'm going to have is 6.63 times 10 raised to the power minus 34 minus 5. So that should give me plus 35, right? So minus 35 plus minus 34 plus 35 will give me 1. So what I have here is 6.63 times 10 raised to the power of 1, right? Good. So on our law of indices, anything that raised to the power of 1 is the same thing as the number, right? So 10 raised to the power of 1 is the same thing as 10. So I'll multiply 6.63 times 10. What I'm going to have is 66.3 meter per second, right? Good. Now if you check from the question, you will notice that our answer is option B, right? Thank you for staying with me. Okay, bye.